All right, everybody, get excited because this is our last section for the whole chapter. So we're going to do just a couple complete the square examples and then a couple writing equation examples, and then we're finished. So here's what I've got. Let's see, I'm going to group my x terms together, I'm going to group my y terms together, and I'm going to move the 31 over. This is exactly the same way we've been doing these for ellipses. And so remember, you also have to factor out the coefficients, and since the x squared is negative, right here, I'm actually going to put the y squared first. Is that cool? So I'm going to put y squared minus 12y plus something. Notice that there was nothing that needed to be factored out of the y squared because that coefficient was just 1. But notice what happens when I take out the negative from the x squared. I'm left with a positive x squared, and also don't forget what's going to happen to this negative 2. I'm factoring out the negative. It's going to change it to a positive 2. So you got to be really careful factoring out the negative sign. That's a really common mistake for hyperbolas, is to forget to factor out the negative from the entire trinomial. So I've got negative 31 plus something plus something. Okay, so now I'm going to go ahead and complete the square. I've got half of negative 12, which is negative 6 squared, gives me 36, and that coefficient is just 1 in front of the y squared, so there's just a 36 that goes here. And then same thing here, half of 2 is 1, squared is 1. And hey, I've got to multiply this 1 by this negative sign, which is going to give me a negative 1 over here. So just be really careful about that. I've got negative 1, which adds a negative 1 to my right-hand side. Now I've got to combine like terms. You guys know the drill for this. Y minus 6 squared, x plus 1 squared. Combine like terms over here, which is just going to give me 4. So now I'm just going to divide everything by 4. Divide by 4. Divide by 4. So my final standard form equation for this hyperbola, minus x plus 1 squared over 4 equals 1. And so one thing that some of you might be thinking, hey, does that make this a circle? Not a circle, my friends, because of this minus sign right here. Not a circle. Okay, so it's actually a vertical hyperbola. It's a vert hype. The center is negative 1 comma 6. Be careful of that switcheroo. And then just the vertical hyperbola just means that it looks like this. Okay? So not a circle. I know we did a lot of equations that look like that for ellipses when it was plus in the middle of the x squared and the y squared and the same number on the bottom. That was a circle, my friends. The hyperbola is not. That minus sign makes a whole game changer. Okay, so just be aware of that. Let's try the second one. Same thing I'm going to do is group my x terms together, and I'm going to group my y terms together. And so when I do that, I'm also going to factor out the coefficient, and I'm also going to move this 161 over to the right. So lots of things going on here, but we've done this a lot with ellipses. So I'm going to take out the 9 first for the x squared. That's going to change that 54x to a 6x plus something. Take out the negative 16 from the y squared, which will change out the negative sign of the 64 and make it a plus. So be really careful again. Can't say it enough about being careful about taking out those coefficients. Plus something, plus something. Okay, now we got to complete the square. Same drill. Half of negative 6 is negative 3 squared. Gives me 9. And a 9er times another 9er gives me 81. Don't forget to multiply by those coefficients. Some of us are still completing the square correctly, but multiplying by the coefficient incorrectly. So again, here I've got a 4 times a negative 16. Be very careful. Gives me negative 64 over here. Okay. Now I've just got to combine like terms, factor, do the whole thing. X minus 3 squared, y plus 2 squared. That gives me a negative 81 over here. And some of you, actually not negative 81, might be negative 144. Some of you might be like, well, hey, how come it's negative? Does that mean I did something wrong? Nope. Not something wrong. We still need to make this coefficient 1 over here, or what the equation equals, I mean. Negative 144 divides here, negative 144 divides here. When I reduce these fractions, this gives me x minus 3 squared over negative 16. Weird. And notice how these negative signs change to a plus. Also weird. So does that mean we have an ellipse? No, not exactly. Let's keep going and just see what happens. Okay, so maybe some of you know what we should be doing now. Because of that negative sign that I have, all I need to do is do a switcheroo with these two so that the minus sign is in the front. So we need, or in the middle, we need the negative sign in the middle. So switch. You're allowed to switch things back and forth. You're allowed to switch them around, whatever. So it's going to be, I'm going to lead with y plus 2 squared over 9 minus, and then I have x minus 3 squared over 16 equals 1. Boom. Okay, so anytime that minus sign ends up, if you end up dividing by a negative and that makes your first fraction negative, then just switch them. Put the positive one first. So this means that our center is 3, negative 2. And this is another vertical hyperbola. So again, it just looks like this. Okay. Let's see. I did do the next two, even though they're really similar. So if you want to pause the video and get this copied down, or if you want to try these two on your own and then check your answers and see if you can get it, that would be fine too. But go ahead and pause if you want to get these two copied down. They're very similar, but there are a couple things on number 4 that I wanted to highlight or talk about just briefly. So after you go through all of your step-by-step whatever for completing the square, this is another one where our negatives cancel here and make a positive, and I had the negative over here. So again, I just switched them. And then remember what happens when the fraction doesn't reduce. 2 over 9 doesn't reduce anymore when you divide 4 by 18. So that just means make the denominator 9 over 2. Think about dividing by a reciprocal. And so there's just a couple things there that I wanted to point out for you that makes this one a little bit of a harder example, but it's still the same process. So that is that. I'm going to go on down here to these writing equations ones. So very similar to an ellipse, there's a couple different ways to kind of tackle these. Some of you really prefer drawing a picture, and I like to be a visual person as well and get a picture going so I can help think through my steps. Some of you might be able to tell right away what the center is and what the a squared is and what the c squared is and blah, blah, blah. That is fine. Some of you will do these faster than others. But if I want to go ahead and get this sketch here of negative 5, 5, and positive 5, 5, using a little bit of common sense there, we can know that the center is right there in the middle at 0, 5. And can I tell right away if this is a horizontal hyperbola or a vertical hyperbola? Pretty sure it's horizontal because there's only 2 vertices in hyperbola. It's going to look like this, guys. We don't even care where the top of the box is, really, because they told us where the vertices were. They were located along the x-axis of this hyperbola, and so that means that it's a horizontal one, which means x goes first. So I'm going to start with x squared minus y minus 5 squared equals 1. Boom, boom. I got to figure out what goes underneath. Okay, so there's a couple things that we're going to do to figure out what's going underneath these fractions. The distance from the center to the vertices is 5. Pretty sure that means that my a squared equals 25. So I can do that part right away. Okay, still haven't done anything with the foci yet though, so I'm going to go ahead and plot those. That's negative 7, 5 and positive 7, 5. So in order to figure out what my c squared is, because remember the foci always are involved with the c, the distance from the center to the foci, that means that my c is 7, so my c squared is 49. So now you guys can remember from ellipses, we're pretty much almost there. All I need to do is use my a squared plus b squared equals c squared formula. My a squared was 25. My c squared is 49. That means b squared is 24. And that's all I needed here to finish my, whoops, not 25, 24. That's all I needed here to finish my equation. Okay, so that means center 0, 5. We already figured that out, and we figured out the a squared and the b squared, so we're finished. Okay, I can do number 6 in a pretty similar way. If I get a sketch going, I have 8, negative 4, somewhere along this line, and 8, positive 4 is up here, so automatically you know that the center is right in the middle, and its center is 8, 0. And can I tell if this is vertical or horizontal? I know it's vertical because the vertices are located above the center and below the center. Okay, so I know that my y squared goes first, and since it's y minus 0, I'm just going to do y squared. And then x minus 8 squared equals 1. Boom, boom. And then really similar to number 5, all we're doing here is we're trying to figure out what my a squared is, and I went from the center to go up to the vertex 4. That's my a. That means that a squared is 16. So that's that part. And then I also need to figure out the foci. So 8 negative 6 and 8 positive 6. So that's down here as a focus, and up here is a focus. So the distance from the center to the foci, well, that was 6. So that means that my c squared equals 36. So again, a squared plus b squared equals c squared. My a squared was 16. Don't know what b squared is, but the c was 6, which means c squared is 36. That means my b squared is 20. So that's what goes under the x. Okay. So pretty similar, not as tricky as ellipses. There's not really as many like details or info that I can give you to write the equation for the hyperbola. The ellipses I think are the hardest ones to write the equations for. Okay, now we have 2 left. We have a vertical hyperbola with the center at 4, 3. And the fact that it's vertical means that my y squared is going to go first. So I'm going to have y minus 3 squared minus x minus 4 squared equals 1. I need to figure out what goes underneath each of those. And so if you get like a brief sketch going of 4, 3, and the center is there. So let's talk about the slopes of the asymptotes here. That means I went up 5 and over 3. So I'm going up 5 and right 3. To get to the corner of my box, you're also going left 3 to get to the corner of your box, which is why there's a plus or minus there. So that's actually very simple to figure out what number is supposed to go where. The fact that we went up 5 means I have 25 here. And the fact that I went right and left 3 means I have a 9 here. Okay, so really simple. That's how to interpret the slope of the asymptote, and that's much easier than having to deal with the foci because there's really no formula that you have to use. So let's do this last one. This is a horizontal ellipse, which means my x is going to go first. So I have x plus 2 squared minus y minus 6 squared equals 1. And then again, just because it's horizontal doesn't change the fact that the slope of the asymptote is still rise over run. So even if I draw a sketch of my hyperbola at -2, 6, that means that I went up 2 and over 7. Okay, I also went up 2 and left 7. That's why there's a plus or minus there. Or down 2 and right 7, down 2, left 7, whatever. But the y change is the 2, so that means that 2 squared is 4, which goes here. And then the x change left and right was the 7, which means 49 goes here. So the slope doesn't change depending on whether it's horizontal or vertical, so just keep that straight. Horizontal or slope is always rise over run, so the top number is always your y number because that's how you graph slope. So just keep that in mind. Other than that, you guys, we are done. Good job. See you tomorrow.